Hey, thanks for joining us today on Uptime Logistics. It's powered by CAP Logistics, and I am your host, Doug Draper. I'm with the Denver Transportation Club, and today we have an amazing guest. We've been talking a little bit behind the scenes about his background, and we're super excited to have him on. It's James Hillman. He's a logistics professional with many years of experience, and he's coming to us from Sparwood, BC, up in Canada. So we're excited to talk to him. And if you had to do an episode title on this one, you could say it's Stories and Musings from a Third Generation Miner. We kind of came up with that one together, but we're going to talk about mining logistics and really about how the mining industry impacts people and communities, and kind of go from there. So we always like to learn a little bit about our guest, James. So why don't you tell us a little bit about yourself, kind of a little bit about your background and how you got in the logistics world.
Sure. Yeah. Happy to do that. So as described, I'm a third generation miner. My grandfather was here in the Crow's Nest Valley area, and he worked in and around the mining industry, whether it was supporting with he was a bit of a tinker or mad scientist. So he made a lot of different equipment and tweaks to equipment. So yeah, he did that. And then my dad got into the industry and worked in the industry up until this past January. And so he had 43 years in the industry with shovels, specifically electric rope shovels. And then myself, I started early, just out of high school. I tried it a bit, but I think maybe I was just too talkative and needed to go and stretch my legs and see what the rest of the world had to offer. So I went out to the coast of BC, had fun out there, worked in the restaurant industry, dabbled in beer and wine. I helped a couple guys start some breweries. And I just tried my hand at a lot of stuff, but then I became a dad. And being a dad requires, as we all know, a lot of responsibility. So my pops said, hey, why don't you come home? And that's what I did. So I've been back in the Valley for now about 15 years, just shy of 15 years. And so I work with a major manufacturer or supplier of mining equipment here in the area. And when you say I'm a logistics professional, I am, but I'm in what I call the merge lane. You guys all drive. You're familiar with the stress and frustrations of the merge lane. My job as an account manager is to manage that space where we as a supplier try to lockstep with the customer. So the customer is the through traffic, and we're just trying to make sure that we can lockstep and get them what they need and get them where they need to go with as little friction as possible. Because you can have the ticker on, but that doesn't mean anybody's going to let you in.
Yeah.
So that's a little bit about me. We'll probably dive deeper.
Yeah. No, that's terrific. That's a great background. Yeah, I was teaching my son how to drive a couple years ago, and I'm like, it's like a big fishbowl. Nothing ever stops. When you get on that highway, you need to make sure you're in merging appropriately. So that's a great analogy for business. Yeah. So that's terrific. So we're the folks listening to us. Obviously, you don't have a pickaxe and you don't have a light on your head or covered with soot. So
no.
That's kind of the mining perception that folks have. So maybe we just start off and talk about what mining looks like in 2020, right? And maybe break down some of the preconceived notions or just kind of what goes on nowadays.
Yeah, I think that traditionally the industry is from coming from different industries. When I first got back into it, I felt it was a bit static. It's a very iterative industry. It's slow to change because most of the equipment is tested and proven. But what we're seeing these days is we're getting a lot more technology in the industry. There's a lot more analysis done. We'll probably talk big data at some point because there's a lot of that happening. So that stereotype of the hard hat and that it exists. There are folks that do still get really dirty, but there's this really interesting mix of folks in the business now where we have technology. We have application engineers, or folks doing analysis on, just like fuel burn efficiency, let's call it AI of a sort, where you need to analyze what's the right thing to have at the right place at the right time. And that's changing a lot. So, it's a challenge for the industry to even attract those folks, because to your point, most people think, you're out there just moving rocks and working on heavy equipment, but that's changed a lot.
Yeah. So you'd mentioned it's traditionally an industry slow to change, right?
Yep.
Is it mostly, you have a mine and this massive infrastructure in order to
Mm-hmm.
do what you're supposed to be doing with digging up ore and things of that nature? Is the slow change just because it's so gosh darn expensive with the equipment, or is it more just a mentality of the workforce there that's kind of, hey, we've always done it this way?
There's a bit of that, like there's a high degree of risk of introducing a new product. Like if you introduce a new product and it doesn't work, the downtime associated with that is enormous. So that cost, that risk of putting a new product into play can have catastrophic effects. So the customer is going to want to mitigate that risk and lessen it. So that's why you see a lot of the same things being done, and you just tweak it a little bit to get an improvement, whether it's, with a shovel and its cycle time being reduced, or a truck that can haul slightly more or slightly faster. Those they seem marginal, small gains actually have an enormous impact once you stretch it out over a year, 2 years, 10 years.
Mm-hmm.
As an example would be, just off the top of my head, so electric shovels will have a cycle time of, say, 30 seconds. So they'll through the face to pick up material to put it into a truck. Well, if you can shave a second off of that, well, that shovel will load, say, 300 trucks. So that's 900 cycles a day. You take those 900, you take 900 seconds off, and you amplify that over the year. That's a big savings. So these little incremental changes mean a lot.
Yeah, I can definitely see that. Let's take a step back with kind of the industries that the mining serves, right? Because again, you're thinking, all right,
Mm-hmm.
coal comes to mind and the basic nature of generating power. But I know we spoke in the last couple of days about other things that people may not realize that the mining industry touches. So maybe some industries that it serves, and expand on that a little bit.
For sure. Well, I think, there's a bumper sticker that goes around in our industry, and that is, if you can't grow it, you got to mine it. So pretty much everything you need is either going to be grown or mined. So the phones or the technology that we're using right now come from mining. So this area here is known for metallurgical coal. So there's two groups of coal. There's thermal coal, which is used for power. And then there's metallurgical coal. And metallurgical coal is the carbon in steel. So if you want anything made out of steel, you need this coal. And so that product is supplied around the globe and used for everything from paper clips to the phone we're talking on right now. So it's you can't get any more important than that at the end, I guess.
Yeah, that's for sure. And I'm glad you made that clarification, because I'm like, they're not mining computers and cell phones and microphones down there.
Nope.
But yeah, you're exactly right. I mean, it's the stuff that makes stuff. You got to be out there. So,
and this, go ahead. Yeah.
No, go for it.
Well, I was just going to put in there like that. It's interesting in this area because when we talk about the stuff that makes stuff, interestingly enough, this area where the met coal, the Elk Valley, historically, this area had a lot of underground mines. And those underground mines predominantly mined thermal coal. So that thermal coal was used to power the steam trains that went through this region. So they're using that product to power a train to haul people and products. And over the years, that became inefficient and then was replaced by, electric trains or diesel trains, pardon me. And now the coal in this area is hauled by those same railways around the world to make railways, trains, etc. And it still employs, the people of this area. This whole area is grown up on that, and is supported by it ultimately.
Mm-hmm. Yeah.
So it ties into that logistical element in my mind, because originally the logistics was powered by the coal, and now logistics powers the coal to get elsewhere.
Yeah. Yeah, that's great. That's a good analogy. So let's jump into a little bit about the logistics of working a mine, right?
Mm.
This in of itself could be an hour discussion, right? But I wanted to maybe talk a little bit about maybe the flow of logistics, how it works. Maybe talk a little bit about um, services and items used to get into the mine, right? I mean, you got trucks and trains to bring products so the mine can run. And then obviously you need to sell it, right? So they
Yeah.
can make things. And then you have the transportation logistics that takes it out of the mine. Obviously, the world makes steel, not just the US. So it has to get out
Yep.
of the country. So
Yep.
maybe talk about the logistics touch points going into the mine to
Hmm.
support it, and then the finished products kind of going out of the mine.
Yeah, well, I think you got to start with where the mine is. You know, a lot of them are quite remote. This one here, fortunately, is on a good bend in the road that you can get people to, because we talked about it before briefly, and that is that I think logistics is life. Like it doesn't, you can't separate those two. So a mine, in order to function, needs people. So that's, I think, really where it starts. Is you got to get the people to the place,
Mm-hmm.
and we see that here in the area of we've got a lot of people coming in and out on their shifts. So you've got an economy built on that, but it's also supported by the outlying areas of, say, Calgary, Lethbridge, Cranbrook, etc. So you've got all these people coming into the space, and then within the mine itself, it's an incredibly complex network of the coal that, wow, I don't know how deep we want to dive on this, but the coal in this area does not lay on flat beds. Hey, met coal is crushed or compressed between layers of rock. And in this area, it's limestone. So those layers of rock don't lie flat, they lie on an angle. And each layer of coal is slightly different grade. So the mines here have to dig up it's a 10-to-1 ratio. You move 10 tons of rock to get 1 ton of coal, hence the cost. But so they have to chase these different grades of coal to blend it for the particular customer. So that is a logistical challenge when you have to move a bunch of mountains out of the way to get at the coal. Then that coal needs to be moved to the plant, and then it'll be blended prior to the plant, get cleaned, and then loaded out onto trains. The trains are, oh man, this is like a test almost of how many cars are on there. I think it's 300 cars. Let's just go with 300 cars. Somebody can fact check me afterwards. You can put it across the bottom. But so they'll load those cars out, and then they put a spray over the top of it so that the coal doesn't blow away, because you expect it to be really big chunks, but it actually is not much bigger than this. Yeah, it's probably even smaller than this phone. It's about the size of this bottle cap. So it's quite granular. They'll spray it. And then most of the coal from this area actually goes to Vancouver's ports. And then from there, it's dispersed. And the cost of that coal is, based, obviously on market value, but it's to port is the price. So that's a part of it. Now, in terms of supplying, on the logistics side, my world and that merge lane, the merge lane occurs when we, as a vendor that supports the mine, we need to get the machines and the parts. We joked about the flux capacitor needing that widget, because when our products go down, the material doesn't move. So you got to get that machine back up. So anticipating those needs, having inventory close or inventory that can be brought in a timely fashion. That's like one of the biggest challenges that we all face.
Mm-hmm.
That's when my life in the merge lane gets very uncomfortable.
Right. Yeah, I can appreciate that. You mentioned that things get blended on site. I didn't even know that. So you have the mine itself, it goes down the street and they literally combine the rocks and churn it up and then put it in is that kind of a very basic
that's kind of it, right?
Yeah.
Yeah, like the coal has like different grades, different content of ash versus, and so they're going to mix it together to get the ratio that the particular customer wants. So it's not just all one kind, there are different grades of the coal, and the coal in this area is some of the highest carbon coal or met coal in the world, actually. So it's sort of the gold standard. So it isn't as impacted by price fluctuation, but it's still impacted.
Yeah. Yeah. So you have some of the best coal in the world up there, and obviously it's 24/7, 365. You don't want it to ever
Yes,
go
sir.
down.
Yes,
Right.
sir.
And so
Yeah.
you're probably getting calls at 3 a.m. to say the flux capacitor just blew up. What the heck are we going to do?
Yeah.
So in those type of instances, I mean, how are you guys preparing or reacting to those type of, just in time? Is there a parts depot that's physically on site? Do you just have the right type of customers you partner with, like a Cap Logistics, to
Mhm.
get it there quickly? Talk about how
Yeah.
you respond to, oh my gosh, situations.
Yeah, like you do your best, and I hearken back to my restaurant days of, you try to hope that you know how many potatoes you need tonight. Well, that's the same thing in this industry. Is you hedge. You understand what's commonly breaking. You understand what's in that wear out phase, and you try to have that. The customer will have some of these items. Let's call them consumable widgets. We'll have a layer of protection, so support for that. And then really you do start to rely on these networks of supply and delivery chain. So we have offices in Edmonton and Gillette, throughout the West, and then our main office is in Milwaukee, and so we'll pull stuff out of there. And then really the flux capacitor is easy. It's about this big. We don't have a flux capacitor, but it would be cool. But we'll get up to parts, that are like, we've like 65,000 pounds, and that becomes challenging to move, right? So you hope that you have that, nearby, because it's not as easy to move, and getting, let's call it 50,000 pounds onto a plane and moved overnight is not the easiest task. So generally speaking, though, here's like just on that, oftentimes what we find is that you can, except for these really terrible moments where you got to move a 60,000 pound part, you can probably move it within North America faster than you can take it off and put a new one on. So let's use that as an example. Your machine goes down. It'll take a day sometimes to get that thing off. Well, you can have the thing you need, the replacement part, already moving, and by the time they're ready, that part's arrived. So you minimize that downtime.
Is your part of your responsibilities to do the actual maintenance? So, hey, here's the new part, and I present it to the repair guy right there at the mine.
Yep.
Is part of your role and part of your commitment to the client to say, we will also put it on and make sure it's running correctly?
Oh yeah, like as a team, we take care of that to soup to nuts, right? We're gonna let you know when we see things that are a problem, and that's there's a word for this, but there's a Japanese word where I want to say it's gamba, but doesn't matter.
Right.
When your touch time on the machine gives you these opportunities to see what's happening in real time. So you've got your planning side of it. You know that the widget should last, let's say, 20,000 hours. But what you want to make sure is that you're having touch time on the equipment so you can actually see what's really happening to it. So we'll take care of that. But that feeds back, or should feed back, into your supply chain or your planning team, so that they can adequately go, okay, it looks like the flux capacitor is giving us some trouble. Let's get one or two moving to support that. So we'll do that. So we'll let them know, hey, you need a new flux capacitor. B, we're going to probably start moving it ahead of time, and then they may already order it before it goes, and then we'll put it on and confirm that it's working. We kind of we'll babysit you as much as we can, man.
Yeah. It's a little bit of guessing. That's a great transition to one of the next topics, was talking about the rise of the smart mine, right? And some modernization. I'm pretty sure you're not having some guy out there just looking with a flashlight to see if the valves look worn. I'm sure there's pretty amazing technology.
We got that guy. We got that guy too. Yeah.
his name's Fred, right?
Yeah, Fred. Yeah. It's on his coveralls.
Yeah.
Right.
So anyway, tell us a little bit about some of the technology out there that's in existence right now that
Yeah.
helps you make those right decisions. So you
Hmm.
minimize the downtime and, more importantly, keep the uptime moving forward. So talk
Yeah,
about
for
that
sure.
a little bit.
Yeah, like what we see in the industry, not just us, but all members that are equipment suppliers in the industry and customers are moving to what they call remote health monitoring. So they, think of it in your car as OnStar, but you want to be able to remotely see what that machine is doing. So that enables you to respond quicker to getting the parts that may be needed. Or what you also see, and this is the advantage of the technology, is that when you do have a problem, some of this technology will self-diagnose now, so that the guy who's showing up to fix it will have a better idea what to do. So we offer those services. We've got folks sitting in rooms all over North America watching screens, which is effectively watching the machine. And then we'll let the customer know, hey, look, this thing over here in the corner doesn't seem quite right. You might want to go take a look at it. So that's one side of the technology. And then the other side of it is, just using technology to tweak the performance of the equipment, having the ability to shave seconds off of the performance. It's that 0 to 60 moment. Through technology, you're up to 60 faster. There's a lot of that going on. And then the big move these days, sort of to backtrack there, but you move people away from the equipment to keep them safer. That's the remote health monitoring side of it. You reduce the touch time physically, which is a big save because this stuff hurts people quite easily. But now we're really starting to look at more and more of that, that semi-autonomous or autonomous equipment, where you take people out of the equation even more, so that they're not in harm's way. They're not getting dusty anymore because they're just sitting in a room. So that's a big movement in the industry right now.
Gotcha. So you're saying that if something needs to be checked, right, just to
Yep.
validate if it's still working, all the way down to an actual repair,
Mm-hmm.
is it like a self-autonomous vehicle, like a robot that's going in there to double check things, and there's somebody 2 miles away that's looking at a screen controlling it?
No, we're not quite there yet, but I wouldn't be surprised if that's coming. But what we'll have is we have sensors on the machine, so we'll be able to analyze the vibrations from bearings, etc., so that when the guy gets there, we go, hey, you need to go look at exactly this spot to check this out. We have not gotten to robots that run around like R2 and reconnect wires for us yet, but yeah, hopefully someday. Now the autonomous side really is part of the equipment operator side of it. Is it you can get, it's like the self-driving car. That the short version is that's the direction of the industry, because equipment on equipment incidents are where most people get, they're big machines. You don't want to be in anywhere near an equipment on equipment collision. Mm-hmm. So if we can get people out of that space, we keep them safer. And like it or not, they perform better. I like to think I'm a great driver, but the computer is probably a better driver than I am. I know it's better at chess than I am. So
yeah, there you go. Nice. Yeah, so that leads kind of into workforce development, right? So we joked at the beginning about a soot-covered face and a headlight up here, and the knowledge base is dramatically different from reality now that we just spoke about that. So talk about workforce development. You're kind of in remote sites that you had indicated. Mm-hmm. You have to have a higher level of worker that understands some technology and things of that nature. What's it like with trying to make sure you get the right people in the right place related to mine, and how you're having difficulty or not difficulty attracting the right talent? Talk about that a little bit.
Yeah, for our team specifically, it's very specialized actually. So it's not as simple as you pull a mechanic or an electrician in. As the industry has changed and the technology on board the machine is improved, it's just not as simple as connecting the red wire and the green wire anymore. So it's very specialized in that sense. So to summarize, I guess it usually takes us 5 years to get somebody up to the level. You're bringing an apprentice in, or just your standard tradesman. It takes 5 years to get them up to where we need them to be. Just simply because when the gear goes down, they have to be experienced and knowledgeable enough to get it back up as quickly as possible. So it takes a lot of time. And it's a challenge to attract folks into this industry because of a bit of the stereotype, and also because it's challenging, it's stressful. It takes a particular type of person that doesn't mind, hey, is it fixed yet? Hey, when's it going to be back up? Is it fixed yet? All right. Because there's a lot of pressure on the line. So yeah, it takes quite a bit of time. And then to your point, it's like, it's tough, but a lot of times it's the Maytag repairman. He sits there a lot and he's waiting. And then all of a sudden, it's like five car alarm, and out we go to the mine to fix this thing. So you wait around, you circle the tower a lot like a fireman, and wait, and then off you go and correct the problem and fix the problem for the customer. So it's a real challenge for us. It's not easy at all. It takes the right kind of person. So it takes a lot of recruitment and training and patience with it. Yeah. And then I think that's something we're going to see even more long term as more technology is involved. You can still troubleshoot it remotely. You can give somebody some advice, or point them in the right direction, but you're still going to need that person on site. That'll never go away. And until the gear is disposable, you're going to need somebody to fix the gear.
So where do you where do you find the folks? So do you have an active recruitment program in universities and colleges, or is it just kind of natural and organic from other miners to just pass it down in the family?
Yeah. There's a lot of recruitment, in the manufacturing side of it. We go to the universities, the trade schools to recruit, and then for ourselves here, we'll actively recruit. But it's interesting. There's a lot of, let's say, on our technical service side, we got like say 6 guys. One of them is a new guy, right? And then maybe one of them will get promoted and move to another location. So we'll bring another person in. So there's a lot of mentorship that goes on in this. So it's not like we go out and hire 6 guys at once. It's a slower process. But yeah, the typical avenues. But for the most part, the selection process is longer because it is such an investment in this person.
Hey, let's talk a little bit about the environmental impact, right? I mean, I wouldn't say it's the elephant in the room per se, but I know that,
yes,
it's,
it
totally you're tearing
is.
up the earth and things, and which are very valid concerns, totally get it. And obviously the industry is very aware of it,
Totally.
What's the, talk a little about that, about the mitigation of the environmental impact and things of that nature.
Sure. Yeah, there is. It is always the elephant in the room. The more requirement for mined materials, if you will, the more demand for that, the more mines that we will probably see. But there are a lot of regulations, particularly here in Canada, North America specifically, that it's not so easy to just open a mine. You have to have all the controls in place, and then the reclamation process. This area is taking great strides to control it. So you've obviously got, everything from like a drop of oil off of a machine, all the way to the dust that it puts out, to the exhaust from the vehicles. It's all tightly controlled. And interestingly enough, there's the environmental side of it, but there's a cost side to that too. Your vehicle idling costs you money. So it's not just, it's bad for the environment, but it also costs you money. So there's those two things that are always being considered. I also like to think, and this is probably the one that rubs people the wrong way, but yes, you can see a mine from space, but you can also see a city from space, and that one gives us the other. Now, to clean up a mine, you go talk to one company, and they do that, and they're regulated and required to do it. It's hard to get a city to clean up. There's a lot more involved in that process. So you see great strides happening on both sides, but people forget that this one over here also has an impact. Probably, I don't know.
Yeah.
That makes a ton of friends, that one.
Yeah.
But they're both visible.
You know, you have a good way of explaining different, your analogies that we've had here during the conversation have been great. I personally can get it, right? I understand what you're saying. So I appreciate it's great analogies and comparisons. So one thing you had mentioned, we're going to talk a little bit about kind of parting shots or things you'd like to end the conversation with. And I'm going to ask you that, but I'm also going to start because I want to make sure we cover it. You would use a term called the life cycle of materials and resources and how that's going to gain importance. I think that's a great statement that needs some more detail on it. So this is the question, what's the parting shot? But I also want you to dive into that one.
Yeah, like my parting shot, it is, it goes back to that city versus mine, like that civilization. Mining has enabled us to do all these amazing things, but along the way, I think that we've spent great energy and knowledge and intellectual power to reduce costs, be more efficient about getting this stuff out of the earth and creating really cool things like iPads and phones and cars that fly probably here shortly, or they'll drive themselves. But we seem to be forgetting that, as we move along, we have bigger cities and we'll probably have more people and we're going to have more mines. But we seem to be forgetting what happens with the stuff after we're done with it. So that material has value at the end. And I would challenge us all that we need to consider that full life cycle. When I sell a product to the customer, it's a new piece of equipment, I talk about the whole cycle of what it costs over the entire life and what it's worth at the end. Well, we need to do the same thing with the materials we pull out of the earth. They have value at the end, but I don't know if we're addressing that. So that'd be my parting shot for everybody in the room.
Well, we've been talking to James Hillman, who first and foremost, third generation miner. That's very cool. You don't hear that spoken very often. So congratulations on that. But he's also a logistics professional and somewhat of a poet in describing, the whole mining industry. So I can't thank you enough for joining us, James. I think we could dive in the future with more specifics on some of the things that we spoke about. But today, I think it was a great summary and really appreciate your time today.
No, it was great to spend time with you. I really enjoy it. Thanks for listening to my musings.
Well, I'd like to thank our audience today for joining us on Uptime Logistics. Of course, it's powered by Cap Logistics, and you can find more information about the show in the description below. Don't forget to like and subscribe to the YouTube channel. And please visit caplogistics.com for all of your logistics and transportation solutions. Thanks again and have a great day.